Let's look at a few more examples on loops. Remember that in week 3, we have written a Java program for moving a car image on a canvas along the orientation of the car. Instead of moving the car continuously forward, what you'll see is that the car will jump from one place to another. Let's try to run the program to see the effect. So we can create a new car, just use the default operator. Call the method carDemo to display the car on the canvas. Say if we want to move the car forward by a certain distance, say 400, you see that the car just jumped from the beginning position to the ending position. If you want to move the car continuously, you should update its image position step by step. I have prepared another program here. In this program, you can see that there's a loop here. So I simplify the program by simply moving the car forward horizontally. You can modify the program to try to move the car in any direction. In this modified program for move forward, I have introduced a loop. In this case, it's a for loop for a given distance given as the parameter. Instead of updating the position of the image by this, the loop here would move the car pixel by pixel. So every time you can see that it's moving forward by 1 pixel for this number of times. So at the end, the car would have moved forward by these pixels. Well, you may want to think about what if this here is negative, that is to move the car backward, and also you want to consider how to move the car along its orientation. Let's consider this simple implementation. Compile the program, there's no problem. The method is car3. Again, create a default instance of car3. Display the car on the canvas. Let's see what happens if you try to move the car forward, say by also 400 pixels. Well, it still just looks as if it jumped from one place to another. That is because our computer is so fast. Although the car was actually moving pixel by pixel, the screen has been refreshed so rapidly that you don't really see it. In order to see the car moving continuously step by step, you have to slow down the processing. Here, I have created a method called pause. By calling a system method sleep, you don't have to worry about the try-catch block at this point. This is basically for error handling in case the system call created some error. So by using this method, you can slow down the processing. What you can do is to introduce the pause statement in the loop. The unit here is millisecond. So every time through the loop, you pause 10 milliseconds. Let's compile the program and create an instance of the car again using the default operator. Display the car on the canvas. Try to move it again by 400 pixels. So you can see that the car is actually moved continuously forward. You can change the speed of the car. Let's say if you want to slow it down, pausing it by 30 milliseconds, run this again. So you see that it's a lot slower. We have also created a simple demo program for you. Instead of moving a car, here you'll be moving a soccer ball. Although World Cup is already over, you can create your own World Cup here. This program is similar to an applet that we have provided you in the first week. When we introduce graphical user interface, you'll actually learn about using event-driven programming for graphical user interface in week 8. So here you can see that a soccer field is being created and a different option. The first one is to simply shoot the ball forward. This is similar to moving the car forward like what we have just seen before. So here you can see that the ball is moving forward, but then it doesn't look too natural because usually when you kick the ball will spin. But then there's no spinning motion here. I just score. You can modify the program by introducing some spinning there. Again, I score. So what I want you to do, just for your own fun, is to complete the method in the shooter class. There are two methods here. Shoot is just to shoot the ball forward without any spinning motion. And then spinning shoot is to shoot the ball forward with spinning motion. You can download the skeleton program from the course website. So have some fun with this program.